Geometry! You get to learn about special right triangles. These are right triangles that pop up quite a bit, and we can identify them based on their angles. And so what's cool about them is if you see one of these, and the two of them are the 45, 45, 90, 30, 60, 90 right triangles, and I'll explain what that is, but those are just the angles. Whenever you have those, the relationship between the sides is always the same. The ratio of one side to the other is always the same. Like, for example, one is always twice as big as another side, and other things like that with square roots. So I'm going to show you those, and we get to learn what those are and then apply that today. So here is a 45, 45, 90 right triangle. So it's a right triangle there, and this is 45 degrees and 45 degrees, which means that, if we have 90 degrees being taken up by the right angle, then you have 90 degrees left to make 180, and so it's split evenly, which means that if those are the same, then these are the same, which means it's an isosceles right triangle because two of the sides are the same. The other special right triangle that comes up a lot is a 30, 60, 90 right triangle. So here you have 90 degrees. The smaller angle is 30 degrees. The larger angle is 60 degrees. And this makes sense if you look across from the 30, you have the smallest side of this triangle. Across from the 60, you have the medium size of this triangle, the altitude. And across from the 90, you have the largest side, the hypotenuse. So again, you look for 45, 45, 90, or 30, 60, 90 in the angles. And no matter what, how big or how small that triangle is, you'll always be able to figure out the relationship between the sides or what the sides are just knowing these angles. So we're going to practice doing what we already know how to do with the Pythagorean theorem to help us derive the special relationship in these triangles. So here these are the same. We have 4 and 4, so it's isosceles, and we want to find what the hypotenuse is. And so we would use 4 squared plus 4 squared equals c squared. So 16 plus 16 equals c squared. 32 equals c squared. That means that c equals the square root, plus or minus, of 32. And let's see, what's the square root of 32? Well, let's see, plus or minus. I know that that's 4 times 4 times 2. Because I knew it was 16 times 2, right? 16 times 2, because I just had added 2 16s together. And so the square root of, that's 16, the square root of 16 is 4 root 2. So I don't know if this is confusing, but you could have written it like this, right? And the square root of 16 is 4. Or the square root of 4 is 2, the square root of 4 is 2, square root 2, so 4 root 2. So that is C. So let's see, if this is 4 root 2, and these were 4, I wonder if that's always just the same number and then the square root of 2. Let's see, let's try this one. So we have the same thing, 6 squared plus 6 squared equals c squared. So 36 plus 36 equals c squared. That's 72 equals c squared. So c equals the square root of 72, plus or minus, but I know it's going to be positive because you can't have a negative length of a triangle. And so then that's c equals the square root of, that's 36 times 2. The square root of 36 is 6, so that's 6 root 2. Hey! It did happen. So what this tells me, and the hypotenuse is always whatever this leg is times the square root of 2. So, and these were 45, 45, 90 right triangles, and I should have said that at the beginning, but these are 45, 45, 90. And how do I know that? Well, if the sides are the same, then the angles opposite are the same also, because the only way for that to form the same size is if the angle's the same. So, because we have 45, 45, 90 right triangle, and every time the leg was, 4, the hypotenuse was 4 times the square root of 2. So whenever, I'm going to clean this up a smidge so that we can look at some relationships here. Whenever we go from here, from 4 to the hypotenuse, we are multiplying by the square root of 2. But if we want to go backwards, then we'd have to divide by the square root of 2. Meaning, let's say you had a triangle. Well, that's great. And it's 45, 45, 90. And you knew that this was 10 root 2. What would be x? Well, it would have to be this thing divided by the square root of 2. So it'd be 10. So knowing how to go back and forth is going to be helpful. So if we go from the leg to the hypotenuse, we multiply by the square root of 2. If we go from the hypotenuse to the leg, we divide by the square root of 2. And that relationship's always going to happen. All right, so now let's take a look at this. It says find the length of the altitude. So what we're doing is we're actually taking this equilateral triangle, because all the sides are the same, and we're cutting it in half. When you cut it in half, what is half of 60? 30. So now this is an example of having a 30, 60, 90 right triangle. So it's like that. And again, my drawings are just a little rough today. I apologize. So what we have here, this is 2. If I cut this in half, then it becomes 1. This is 1. We want to find the height, the altitude. So we use our Pythagorean theorem. 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. X squared equals minus 1, that's 3. And so that means x equals the square root of 3. Okay, so if the height is the square root of 3, let's see if we can find a relationship here. Whenever, if this was x, this is 2 times x, and this is x times the square root of 3. So what I'm saying is, let's say you're given a triangle, and you have to know that it's a 30, 60, 90, and across from the 30 degrees is always the smallest angle. So let's say this is 4. Then the hypotenuse is double. It's 2 times that. So this would be 8. And the altitude is 4 root 3. It's whatever this is times the square root of 3. So if you can remember this, that the hypotenuse is double the short leg, and the height is the square root of 3 times the short leg. Then you'll be able to figure out any triangle they give you. So here are those relationships. And this is something I would memorize. These are things you have to know. You can't look it up. I mean you can when you're not in class, but these are things that if you just know off the top of your head, you're going to save yourself a lot of time. So remember the 45, 45, 90. Makes sense that these two sides are the same because the angles are the same, so they're x and x. The hypotenuse is just that value times the square root of 2. The 30, 60, 90 you have the smallest side is your x, the hypotenuse is double that, and the height is just that number times the square root of 3. So we're going to practice using these to solve some. So here we are with some examples, and I already wrote the reference triangles at the top, and that's what we call these. We refer back to these relationships to solve them, so they're called the reference triangles. So the first thing to know, so while you guys draw those onto your notes, is you have to identify what kind of triangle it is. So you have to look at the angles. So first, look at the angles to know which one it is. Is this a 45, 45, 90, or is it a 30, 60, 90 triangle? Okay, so this one, first off, it's got to be 45, 45, 90. M and N, we know, are the same thing. The hypotenuse is 8 root 2, so that I remember that if I have that divided by the square root of 2, then I get 8, and that must be what N and M. So M equals N, which equals 8. So those both equal 8. This one is a 30, 60, 90 right triangle. It has to be 60, right? Because 90 right here plus 30 gives you 120, and 180 minus 120 is 60. So across from the 30 is y, and that's like our 1. So what do I know about x? Well, darn it. If I knew what y was, I could tell you x because I know it's double. But I don't. I know the altitude, which this is whatever y is, right? Because you would take y and you would multiply it by the square root of 3 to get the altitude. So 2 root 3 divided by the square root of 3 gives us 2, so that's what y is. And then that means that x is 4 because you double it. So x equals 4, y equals 2. So I'm able to do these just by looking at them. I don't have to set up a ratio. I don't have to set up a proportion and cross multiply. I don't have to do anything other than just look at them and answer these. So that's 45. That means this has to be 45. That means that M is going to equal N. Those have to be the same. Now, the relationship, if I want to go from the hypotenuse to this, is I have to divide by the square root of 2. So 6 divided by the square root of 2. I have to rationalize. I have to multiply by the square root of 2 over the square root of 2. That becomes 6 root 2 over the square root of 4, which is 6 root 2 over 2. That divides, and you get 3 root 2. So M and N equals 3 root 2. Now that's weird because it's so much easier to go the other way. It's so much easier to say, oh, here's a 45, 45, 90, and this is 10, and this is 10, so that means this is 10 root 2, right? Multiply by the square root of 2. But it makes sense if we, actually I'll just leave that. If we have 3 root 2 and we want to multiply by the square root of 2 to get the hypotenuse, well, that's 3 times the square root of 4, which is 3 times 2, which is 6, which is what it was. So this, though it's difficult maybe or a little bit awkward to go the other way, you can do it. If this is 60, then this is 30, so 30, 60, 90. Again, that's the one I really want to know. Or if I knew, I could easily work this. But from y to 6, so I have to do 6 divided by the square root of 3. Because if I was going from y to the altitude, I would multiply by root 3. So now I have to do the opposite. I have to divide by root 3. So again, I have to rationalize. So I get 6 root 3 over the square root of 9, which is 3. So 6 root 3 over 3, which is 2 root 3. So that is what y is. Y is 2 root 3. Now x is double. So 2 root 3 times 2 would give me 4 root 3. there you go. So practice that relationship. Get familiar with it. I can do these quickly because I've been doing them for so long, but get used to that relationship 45, 45, 90. If the x and the x, the two legs are the same, the hypotenuse is that times root 2. Same thing with the 30, 60, 90. If you know the short leg, you can multiply it by 2. If you want to go the opposite way, you have to divide by 2. If you know the short leg, the altitude is that times the square root of 3. But if you know the altitude, which is what we just did, you have to divide by the square root of 3. All right. So these ones, we're going to find the missing length. So it's just more practice, like what we just did. You know what? Actually, what I want you to do is I want you to do these 4 and pause the video and come back and see if you get the same answer as me, because I want you to try these. And then I'll explain it as I go, but I want you to try these on your own. So pause the video, come back when you're done to this video, see if you get the right answers, and then when you come back to see me in the Zoom room, we can check your answers, or, well, you'll have the answers, but we can go over any questions you have. All right, so pause the video and come back and check your answers. Okay, so I'm going to do these to explain as I go as well. So that's 60, 30, 60, 90. Oh, finally, I know that one's 5, so that's 10, and this is 5 root 3. I have to multiply by the square root of 3. Okay, 45, 45, 90, that's 8, this is 8, and this is 8 root 2. This is 30. Okay, so I don't know n, but I know that 12 was double, and okay, so this must have been 6, and then that, it makes this 6 root 3, because you have to multiply by the square root of 3. 45, 45, 90 means, oh, this is a nice one. Okay, so m and n are the same. And normally you would multiply this by root 2. So I'm going to go the other way. So I'm going to divide by the square root of 2. So 3 root 5 divided by the square root of 2. I got to rationalize. So that's 3 root 10, you can multiply those because they're both radicals, over the square root of 4, which is 2. And that's all. You can't reduce. Yeah, so that's it. So 3 root 10 over 2. Oh, ugly number. Okay, this next one, great question. You have to use all of them, all of your stuff. So what I want you to do is try this one, pause the video again, come back, check your answer, and I'll work through it with you. All right, so this is 45, 45, 90 from the start. This is 7. That means that f7 divided by the square root of 2, rationalize. So that's 7 root 2 over 2. Ugh. So that's my 2 legs, and if this is a 60 degrees, this is x, this is 7 root 2 over 2, and I need to find x. Well, that's okay, so this is double whatever x is. So if I divide it by 2, so 7 root 2 over 2, dividing by 2 is the same as multiplying by 1/2. So that would be 7 root 2 over 4. That's what x is. Because it's half of whatever that hypotenuse was. All right, guys, come back and see me in Zoom.